The Bingham Mills Dam is an abandoned old dam located on the Roloff-Jansen Kill, which is a 54-mile-long tributary of the lower Hudson River in New York. The Roloff-Jansen Kill joins the Hudson River in 5 miles south of the city of Hudson. The dam is located at 6 miles upstream of the mouth of the Roloff-Jansen Kill. The original dam used to provide hydropower for the mills nearby. It was about 50 meters wide and about 5.3 meters high. On the left side, the dam has a spillway with 4 floodgates. The spillway crest is about 2.2 meters high. On the right side, the dam body had been lowered to 1.7 to 3 meters above the rock foundation when it was abandoned. The Roloff-Jansen Kill is one of the major freshwater tributaries of the Hudson River. It is relatively undisturbed and accessible to anadromous fishes. The 6-mile reach from the Bingham Mills Dam to the river mouth provides favorable habitat conditions for a variety of coastal migratory and resident freshwater fish species. The upstream channels have wild trout, stocked yearling and brown trout, and other resident fish species. The reach just downstream of the dam is very steep and consists of several waterfalls. The steep reach is about 175 meters long and has an average channel slope of about 5.7%. The Bingham Mills Dam and the waterfalls near the dam act like barriers for fish to migrate to upstream channels. The reservoir of the Bingham Mills Dam is a single channel consisting of 2 gentle bends. Most of the channel has a sand gravel bed, with some isolated spots of bare rocks. The upstream channel is shallow and one can see the gravel bed clearly. A floodplain with vertical bank slope occupies the right-hand side of the river. In the upper part of the pond, dense vegetation and forest grow on the bank slope of the left side of the river. In the lower part of the pond, water becomes slightly deeper. A single-span bridge across the river is located just upstream of the dam. A management option is to remove the dam, since it is no longer used. Before the possible removal, it is necessary to assess the quality and quantity of the sediments in the dam reservoir, and determine the potential hazards if the sediments are reintroduced into the environment. The research team conducted a field campaign in August 10 to 12, 2016. The team measured the bathymetry of 15 cross-sections, including 2 cross-sections downstream, and 13 cross-sections upstream of the dam. The team also surveyed the talweg elevations of the downstream channel. The team collected surface and subsurface sediment samples by grabbing or coring to determine the horizontal and vertical variations of sediment properties. A total of 12 sampling sites were collected, including 10 core samples, and 2 grab samples. It is found that the pond sediments are mostly sand and gravel, with very little amount of silt and clay. It is estimated that the erodible sediment in the reservoir is less than 1.4 meters deep, and about 9,126 cubic meters in volume. A depth average 2-dimensional numerical model was used to simulate the sediment erosion after the dam removal. The numerical simulation shows that headcut erosion starts from the dam site at the initial period after a dam is completely removed, and then migrates upstream with time. Most of the sediment in the reservoir is washed downstream, and the bed is eroded to the hard bottom within a large flood event. The total eroded sediment is about 7,370 cubic meters. The collected data and derived results can be used for future studies on the feasibility of removing the Bingham Mills Dam, and the potential impacts on the downstream stream water quality and habitats. However, removal or preservation of the dam always involves costs and benefits. The decision should be decided by state agencies, engineers, researchers, dam owner, and local community.